All right, so for today, what we want to do is look at another part of Standard 8NS1. It's very easy. It won't take me long to go over this. It says for rational numbers, show that the decimal expansion repeats eventually or terminates, and then convert a decimal expansion which repeats into a rational number. But I will tell you this part, and I'm going to underline it. This part right here is a little more detailed. So we're going to say that for tomorrow, but when I end the video today, right before I end it, I'm going to go into something that will help you with this part right here. All right, so let's go ahead and look at converting fractions to decimals. So we want to convert a fraction to a decimal. We're going to use TMO, which just means top in, bottom out. And we're going to see if our decimal is going to repeat or will it terminate. So I'm going to use TMO here. And when I say top in, bottom out, it's just long division. But after you T-bow, you want to make sure that you add, to change it to a decimal, you're going to add the decimal and follow it with a 0. All right, so let's put this in and that out as far as our division bar is concerned. I'm going to put the 3 in, but then I'm going to add the decimal and I'm going to follow it with a 0, but make sure that decimal gets moved up, okay? And I'm going to just start off with 5 and a 3. 5 won't go into 3. If you're not good with the division process, you can come over to the side and just skip count by 5s. And I'll take you through it. Everything over here is larger than 3, so 5 will not go into 3. So when you write a 0 in the quote, this is called a quotient. When you write a 0 in the quotient, you subtract the 0. And then after you subtract, you bring down. When you bring down, you always start over. So you can just go back over here and look. How close can I get to 30 without going over? Exactly 30. That's 1, 2, 3, 4, 5, 6. 6 groups. Here I get a remainder of 0 with nothing left to bring down. This is known as a terminating decimal. My remainder is 0. So this terminates in the tenths place, guys. It's 0 and 6 tenths. If you look at B with T-bow it, this goes in and this goes out. Follow it with a decimal and a 0. Bring your decimal up. And skip count by 8. 8 won't go into 1. Everything over here is larger than 1. Write a 0, subtract a 0. And when you bring down, you just start over. The closest you can get to 10 without going over is just one group of 8. I'm going to have to regroup. 10 minus 8 is 2. Now, here I have a remainder of 2. But you just can't put 0 and 1/10 remainder 2. That doesn't make any sense. So what you continue to do is just add zeros. You can do that. And how close can I get to 20 without going over? Once you bring down, start over. 2 groups. Well, 2 groups of 8 is 16. Regroup, that's 1, that's 10, 4. Okay, still I don't have a remainder of 0. So I'm going to add another 0 and bring it down. I can get 5 groups of 8 out of it. So this is, again, this one is also terminating. And it ends or it terminates in the thousands place. 5 stops in the thousands place. Okay, there are 2 ways you can do C and D. I'm going to show you one way on C and the other way on D, okay? Make sure you have this written down. I'm about to erase it, so pause the video if you need to write it down. So on C, one way is to look at your mixed number and decide which part of that mixed number is whole. So if I look at the mixed number, 1 is the whole number part. So with whole numbers, when you write them in decimal form, the whole number sits in front of the decimal. So all you have to do is worry about what is sitting behind the decimal, okay? So I know 1 is a whole number and whole numbers sit in front of the decimal. So just figure out what's behind. To figure out what's behind the decimal, only T-bow 3/4. Add a decimal and a 0, bring it up. 4 won't go in a 3. Bring down the 0. 4 will go in a 37 times. That's 28. You're going to have to regroup. Add another 0. I don't have a remainder yet. 4 goes into 25 times. So now, since I already know what's in front of my decimal, the 1 is in front of my decimal. The only thing I need to be concerned about is what is behind my decimal. Behind the decimal here is 75 hundredths. So 3/4 is just 75 hundredths. So when I have 1 and 3/4, it just becomes 1 and 75 hundredths. So whatever is behind your decimal in this division process goes behind the decimal here. Okay, that's one way of doing it. I'm going to show you the second way on the same problem, okay? So I can also take 1 and 3/4 and change it to an improper fraction. 4 times 1 is 4, plus 3 is 7. So basically, I can T-bow 7/4. Now, my preference is just to keep the whole number 1. This is my preference to do it this way. But, my preference may not be yours, so do what you want to. I can get one group of 4 out of 7. Subtract and bring down to 3. I can get 7 groups of 4 out of 30. Regroup. Add a 0 and bring it down. And I can get 5 groups of 4 out of 20. So I can get 1 and 75 hundredths that way. And again, this is terminating. I get a remainder of 0. But I prefer to keep the whole number. But again, it's totally up to you. All right, let's take a look at D. All right, on D, I'm going to keep this part, and it's going to sit in front of the decimal. Then I figure out what goes behind the decimal by T-bowing 7/10. Or if you know 7/10, just write it. 10 won't go in a 7. Write a 0, subtract a 0. And 10 will go in a 70 exactly 7 times. So whatever is behind the decimal here goes behind the decimal there. So negative 2 and 7/10 is just equivalent to negative 2 and 7/10, negative 2.7. Now, some of you are going to prefer this method to change it to an improper fraction. 10 times 2 is 20. 20 plus 7 is 27. You'll look at it as negative 27/10. And then you can T-bow that way, but that's completely up to you. You're still going to get negative 2 and 7/10. Everything up here was terminating because we got a remainder of 0 with nothing else to bring down. Okay, let's take a look at E through H. All right, E, same process, in and out. Follow it with a decimal and a 0, bring your decimal up. Just skip count a little bit. How many groups of 9 can you get out of 1? None. Write a 0, subtract a 0. Bring down, and then you just start over. How many groups of 9 can I get out of 10? 1. Subtract that 9. 10 minus 9 is 1. Okay. I get a 1 again. So I want you to notice something, guys. I'm gonna backtrack. When I subtracted, I got a 1. My remainder here was 1, and then I brought down. Okay, so had a remainder of 1. And then I said, how many groups of 9 can I get out of 10? 1. So I subtracted the 9. That's because one group of 9 is 9. Look what I get again for a remainder. I get another remainder of 1. Then I add a 0 and bring it down. How many groups of 9 can I get out of 10 again? 1. When I subtract 9, I still get another remainder of 1. If you keep getting the same remainder, guys, the number in the quotient, which is the number up here, is going to keep repeating. When you keep getting the same remainder, the number in the quotient is going to keep repeating. So I keep repeating these ones because I keep getting a remainder that's the same. So this is what we call a repeating decimal. In a repeating decimal, the remainder repeats and the numbers in the quotient repeat. So instead of writing all these ones, I could just write 3 of them and put ellipses, which means and so on. Or I could just write one of the digits that's repeating, and that only digit that's repeating is the 1, and use bar notation. Express it either way. But again, if it's a repeating decimal, the remainder repeats, and I'm just going to put in digits and then and digits, digit or digits, and this is what we call the quotient up here. In the quotient, repeat. So if this happens or this happens, the digits in the quotient repeat. It's a repeating decimal. All right, let's take a look at 2/3. Follow it with a decimal and a 0. 3 won't go in a 2. Write a 0, subtract a 0. I'm going to skip count by 3. And the closest I can get to 20 without going over is 18, which is a group of 6. 6 groups of 3. Subtract the 18. I got a remainder of 2. Okay, I get that would be 6 again. And even when I subtract, I still get another remainder of 2. I keep getting a remainder of 2, had a remainder of 2 here, had a remainder of 2 here, and a remainder of 2 there, which tells me that 6 is going to keep repeating. So I'm just going to write it in bar notation. I'm just going to write 1 6. All right, make sure you got that down. I'm about to erase it, okay? All right, here I'm going to keep the whole number 5. And T-bow 5/12 to see what goes behind the decimal. Gonna add a decimal and a 0 and bring it up. And skip count by 12s just to see. 12 won't go into 5, so I write a 0, subtract a 0. I got a remainder of 5 there. Bring that down. 12 goes in 54 times 1, 2, 3, 4. Gotta see what the remainder is here. Here the remainder is 2. So I had a remainder of 5, now it's a remainder of 2. Nothing is repeating yet. All right. How close can I get to 20? Just one group. That's 8. Nothing repeating. A remainder of 5, remainder of 2, remainder of 8. And that's going to be 72. That's 6. Oh, here I had a remainder of 8. And I got a remainder 8 again. So I can tell you that things are about to repeat. Another 6, 72, remainder 8. So now I keep getting a remainder 8, remainder 8, remainder 8. That tells me that 6 is going to keep repeating. So what I'm going to do is write 416 and only put the bar over the 6 because the 6 keeps repeating. All right, I'm going to do H and then I'm going to move on, okay? You pause the video and you try H on your own before I do it. Go ahead and do that now. All right, this is what you should have. I'm going to keep this -4. And I'm going to T-bow only 3 11s. Add a decimal and a 0. 11, 22. I'm just going to skip count by 11s. 11 won't go into 3. Write a 0, subtract a 0. 11 goes into 32 times. I get 22. Here I had a remainder 3. Remember that, okay? We need to see when it starts repeating. 10 minus 2 is 8. I got a remainder 8. Okay, so I had a remainder 3. Then I got a remainder of 8. Okay. 66, 77, 88. That's going to be 1, 2, 3, 4, 5, 6, 7. Okay, so far nothing's repeating. 10 minus, oh, okay. 10 minus 7 is 3. Okay, now I got a remainder of 3. Add a 0, subtract a 0. Add a 0 and bring it down. Okay, that'll go 2 times. I got a remainder of 3 and a remainder of remainder 3, remainder 8, remainder 3, remainder 8, which tells me the 2 and the 7 are going to repeat, okay? So instead of writing 2 and 7, I'm just going to write a 2 and a 7 with dot, dot, dot multiple times. I'm just going to write a 2 and a 7 and put a bar over it. Now, you could have written it like this and so on. It lets me know the 2 and the 7 keep repeating. All right, this is what I'm going to give you for homework, guys. So we're not going to worry about that right now. I'm going to show you this. And I may have changed your homework up. And we may just do that tomorrow in class. All right, to convert a terminating decimal to a fraction, you write it the way you read it. So up here, all of these decimals were repeating. If the remainder repeats or the digits in the quotient repeat, it is a repeating decimal. Here, all these were terminating. I got a remainder of 0. But these were changing fractions. These were fractions to decimals. These are going to be decimals to fractions, guys, okay? Decimals to fractions. All right, so you just simply write it the way you read it, but you got to understand place value chart. This is the ones. Then you got your decimal. 1 place behind the decimal is tenths. 2 places behind the decimal is hundreds. 3 places is thousands. 4 is 10,000s, and so forth, guys. So this 7, according to the place value chart, ends in the tenths place. Anything sitting in front of the decimal becomes a whole number. So this is the whole number 6. And then you just write 7 tenths. 6 and 7 over 10, you're done. This will sit in front, this is your whole number part. It's -2. And the 7 ends in the hundreds place. 2 numbers of the decimal is hundreds. So it's -2 and 57 hundredths. That's all you do. The 5 ends in the thousands place. I'm just looking up here. 3 places after the decimal is thousands. 1, 2, 3. So I write this. I don't put the 0. I just put 275 thousandths. Now you can put a 0, but that's pointless. Okay, so I don't do that. What I'm going to do is simplify these. When I see things that end in zeros, 2 zeros, or quarters, 50 cents, 75 cents, anything like that, I know it's divisible by 25. And I just think about how many quarters make $2.75. Well, 8 quarters make $2. 3 more quarters make 75 cents. So that's 11 quarters total. Then I just think about how many quarters make $10. Well, 4 quarters make $1. So 36 quarters would make, I don't know, it would be 9. Okay, 4 quarters make $1, but I need $10. So I'm going to need this 10 times. That's 40 quarters. Make $10, okay? So that's 11 over 40. Or you could think of it like this, guys. You could say, how many quarters make $1? Well, 4. Well, how many zeros are left over? 1 and add it there, okay? So that's called putting it in simplest form. Here, this 5 ends in this is 1, 2, 3, 4 places after. 1, 2, 3, 4 places after is 10,000 in the 10,000s place. So this is going to be negative 75 over 10,000. I see 0, 0, and a 7 and a 5. So I'm going to divide both of them by 25. How many quarters make 75 cents? That would be 3. Now all I need to do is think of how many quarters make $1. That looks like $1. 4. How many zeros will be left over? 2. So that's negative 3 over 400. That's an easy way to simplify. All right. So next we're going to get into writing repeating decimals as fractions. I will not teach that today. That's this part you're going to see tomorrow. But I am going to go over this part, okay? Because you need this in order to be able to do that. So this is the only part I'm going to go over. I'm going to show you a little video first. So let me just recap. So far, we've learned how to change a fraction to a terminating decimal, a fraction to a repeating decimal, and decimals to fractions, okay? So let me show you the little video that's going to help you with repeating decimals to fractions tomorrow. So you all watch this.
Have a lot of fun. Multiplying decimals by 10, 100, and 1000. You know, when you multiply a number by 10, you add a 0. When you multiply by 100, you add 2 zeros. And when you multiply by 1000, you add 3 zeros. Now let's see how that works when there's a decimal involved. You can think of regular whole numbers as including a decimal point, even if we don't usually see it. So 23 can also be thought of as 23.0. It's the same thing, it's just 23 and no fractional parts. No big deal there. When I multiply 23 by 10, you know we'll get 230, because when we multiply by 10, we put a 0 on the end. These two values are the same. So if I multiply 23.0 by 10, the answer will be the same. Look what happens with the decimal point as we do that multiplication. The decimal point moves one place to the right. 230 point. There's no digit after this, so we can leave the decimal point off and just say equals 230. Let's do another one. 57, which is really the same as 57.0. If I multiply it by 10, I move that decimal point one place to the right. 570. The same answer as if we just said put a 0 on the end because we're multiplying by 10. This understanding really helps when we have to multiply decimal numbers by 10 or 100 or 1000. Let's say I have the problem 45.34 and we've got to multiply it by 10. Before this video, you might have just set it up and worked out a multiplication problem. But you don't need to do that now, do you? Instead, now you know that to multiply by 10, you can move the decimal point one place to the right. So 45.34 times 10 is 453.4. And what if we had 5.248 and we have to multiply it by 100? 100 has 2 zeros. We need to move the decimal point 2 places to the right. 1, 2, 524.8. And what if we had 1.0457 and we had to multiply that by 1000? 1000 has 3 zeros, so we're moving the decimal point 3 places to the right. 1, 2, 3. 1045.7. Okay, now let's consider very small decimal numbers like this. And we're going to multiply by 100. Move the decimal point 2 places to the right. 001.5. Does that look right to you? I moved the point correctly, but what's up with those zeros? Do we normally write 1 as 001? Of course not. Those zeros are just empty placeholders telling us 010s and 000s. We don't need them at all. In our answer, we just show 0.015 times 100 is 1.5. What about this one? We have to multiply 0.00368 by 1000. We're going to move the decimal point 3 places to the right. 1, 2, 3. And we can dump those place-holding zeros at the beginning. So we've got our answer, 3.68. First you do the multiplication step and move the decimal point. Then remove the place-holding zeros afterwards. And if you happen to have a bunch of zeros in the middle of the number, leave them right there. In this one, move the decimal point 1, 2 places, and we get 400.06 as our answer. When zeros are in the middle of the number, they are important. Okay, now I think you're ready to rock. See you soon on Let's Do Math.
Okay, so you all should see that multiplying by powers of 10 moves the decimal right. And it moves it to the right the same amount of spaces as zeros that it has. So we're going to take a look at just these examples, and you tell me what power of 10 I'm multiplying by. All right, and let me show you something. 10 to the first power is the same as 10, because this 1 just indicates that it has 1 0. 10 to the second power is the same as 100, because this 2 indicates that it has 2 zeros. Or it's 10 times 10. 10 to the third power is 1,000. This 3 indicates that I have 3 zeros, or it's 10 times 10 times 10. 10 to the fourth power is the same as 10,000. This 4 indicates that I have 1, 2, 3, 4 zeros, or I multiply 10 times 10 times 10 times 10, okay? All right, so with that being said, you can either tell me, when I ask you what power of 10 that I multiply by, you can tell me something from this column, or you can give me the exponential expression, okay? So here, the decimal is in between the 0 and the 1, and here it's between the 2 and the 3. So that has to mean that I move my decimal 1, 2 places to get it to be between the 2 and the 3. Well, what has two zeros? 100. So I multiply by 100. But you can also say I multiply by 10 to the second power. All right, here my decimal is between the 0 and the 1. Here it's between the 1 and the 2. So since it's between the 1 and the 2, it went from 0 to 1 to between 1 and 2, only moved it one place. So What has 1 0? That would just be 10, or 10 to the first power. Here the decimal is between a 0 and a 1. Here's between the 4 and the 5. So that indicates that I moved it 1, 2, 3, 4 places. So you find the power of 10 that has 4 zeros. That would be 10,000, or 10 to the fourth power. So you're going to pause the video and you're going to try 4, 5, and 6 for me. Then unpause it to see if you got it correct. All right, here the decimal is between the 0 and the 1. Here's between the 3 and the 4. So that indicates that I move it 1, 2, 3 places. What power of 10 has 3 zeros? That would be 1,000. Or you could say I multiply by 10 to the third power. Here it's between the 2 and the 4. Here it's between the 4 and the 1. So that indicates that I moved it 1, 2 places. Moving the decimal to the right 2 places indicates that you multiply by 100 because it has 2 zeros. Or I can say 10 to the second power. On 6, it's between the 2 and the 4, and then it ends between the 4 and the 1, which indicates that I moved it 1 place. Well, what power of 10 has 1 0? Well, that would just be 10, or 10 to the first power. All right, what you're going to do now is go ahead and try the homework that I've uploaded for you, okay? All right, thanks, guys.